Hello class, good afternoon. So if last meeting we talk about or we describe a star and how our stars form and change, and we also talk about the stars differ in sizes. So this time let's talk about the description of stars. First is the Antares. It is under red supergiant wherein its diameter is 480 million kilometer and the size it is 330 times bigger than the Sun. Betelgeuse, a red supergiant, 600 kilometer the diameter, and it is 400 times bigger than the Sun. Epsilon Argei, red supergiant, 1,700,000,000 in kilometer, and it is 1,200 times bigger than the Sun. Aldebaran orange giant, which is 50,112,000 in kilometer, 36 times bigger than the Sun. Capella, a yellow type, 16,704 kilometer, 12 times bigger than the Sun, and the Sun is a medium type, which is 1,391 kilometer. So after the description of the stars, where we look about the types, the diameter, and sizes compared to the Sun, this table talks about the color and temperature of the Sun. If the Sun is blue, it means that it is hotter, and if the Sun is red, it is cooler compared to the blue stars. So blue stars is the temperature of blue star 25,000. So the temperature of a blue star is 25,000 K to 60,000 K. So example is the Vega. It is a blue star, our most massive and the hottest. Next is bluish white star, 11,000 K to 25,000 K. Example Epsilon Orionis and Rigel. Next is white star, 7,500 K to 11,000 K. Sirius, and next is the yellow white star, which is 6,000 to 7,500 K, Delta Aquilae. Next is yellow sun, orange 3,500 to 5,000 K, Arcturus, and the red star is 3,500 K, Orionis. So red stars are the coolest stars. Stars different in brightness. So the brightness of the star is measured using absolute magnitude and apparent magnitude as bases. So the magnitude allows the astronomers to rank how bright appear to the humans. For the absolute magnitude, a measurement of how bright a star would appear if viewed at equal distances with other stars. So the brightest known stars have absolute magnitude of -9, and the dimmest star has absolute magnitude of about 20. So the brightest so the lower the star's magnitude, the brighter it is. So the stars with negative magnitudes are brightest of all. Next is the apparent magnitude. It measures how bright a star appears from Earth. A while ago, absolute magnitude, it measures the brightness of the stars at equal distances with other stars. While this apparent magnitude, it measures how bright a star appears from Earth. So the apparent magnitude of the brightest star in Earth's night sky is Sirius, which is negative 1.46. The dimmest star that can be seen from Earth with unaided eyes have apparent magnitude of about 6. Star's brightness is based on its surface temperature. So the brightest star is Sirius A. The second star nearest to the Earth is Proxima Centauri, which is around 40 trillion kilometers away. So the light of Proxima Centauri reaches us in 4 years. A light year is the distance light travels in 1 year. So 1 light year is about 5,878,000,000,000 miles, or about 6 trillion miles, or 9.5 trillion kilometer. So the nearest star to the Earth is the Sun. The Sun is about 150,000 or 150 million kilometers away from the Earth. So the Sun appears to be biggest and the brightest star because of its distance to the Earth. However, it is not the brightest star. The apparent brightness of a star depends on their distance from the Earth. So stars that appear bigger and brighter are those that are closer to Earth. So a star's brightness is based on its surface temperature. So the brightest star is Sirius or Sirius A. So this is the apparent magnitude. So this is the Sun, full moon, Venus, Jupiter, Mars, Sirius, Alpha Centauri, Betelgeuse, Polaris, and so on. So this one is the measures of how bright a star appears from Earth. So the brightest is the Sirius.